Good morning, all. I hope everyone doing fine in this pandemic situation. Welcome to this session. So this webinar organizing by Bhoj Reddy Engineering College for Women, Saidabad in Hyderabad, Telangana. So Department of EEE organizing this webinar on power intelligence and assist management in smart grids. So first of all, our sincere gratitude to the management of Bhoj Reddy Engineering College for Women for accepting our invitation and organizing in this pandemic situation this webinar. So to the management and principal sir, Dr. J. Madhavan sir, and convener sir, convener R. Manju Bhargavi, associate professor and HOD, Department of EEE. Thank you, madam, for organizing this webinar, and coordinators. So V. Sri Lakshmi Vani, assistant professor, Department of EEE. Thank you, madam, for coordinating this session. And about Bhoj Reddy Engineering College for established with an with an excellence of to give a great future to particularly women. So women empowerment. For that reason, they started this college, one of the most prominent engineering colleges in. So not only electrical department, computer science, electronics, and mechanical, and other departments are there. So from the last 2 decades, it giving this college giving excellent students in the society. So they are contributing like this: smart grid systems and renewable energy applications. And recent trend is e-vehicle. So in the e-vehicle also we are conducting some national level workshops. Recently also we are organizing in this month in 2022. And for computer science and information technology is going in the industry, in that those areas we are giving the solutions to the engineering graduates and postgraduates and research scholars. And we are conducting faculty development programs, workshops, internships also we are organizing. And about the content today, the power intelligent in assessment. The content here we will discuss electricity sector in India. What is the electricity sector in India? Why should we people move to the smart grid? Why should features of smart grid? Features of the smart grid. And today everyone, we people are depending upon the conventional grid, right? So the difference we need to know between the conventional grid and the smart grid. So what are the key factors of smart grid? Why smart grid only? And what are the ongoing projects current here? The electricity sector. Firstly in 1897 in Darjeeling they started. In Darjeeling they started first power sector. Later they developed a hydro power station in Sivasamudram in Karnataka during 1902. 1902 they started in Sivasamudram as a hydro power station. And the electricity sector in India had an installed capacity of 350 gigawatt, and it is the largest. It is one of the largest sector, and world's third. We are the capacity which we are using in India, grid connected power or generation of the power also 350 gigawatt means almost we are in the third place we are the customers, right? We people are the customers. We are utilizing the power. So we are first we need to generate the power. So generation side, the installing capacity, whatever it may be, whether it is producing the huge amount of the power and in the renewable energy technology, right? Energy sources. Everyone are moving to the smart grid, right? So at that point, at the same time, the conventional energy sources all over the globe, if you are considering all over the globe, 80% of the power we are generating from the conventional energy sources only. But by using the conventional energy sources, the disadvantages, what is the effect on the environment, each and everyone know, right? So we need to reduce the carbon dioxide emissions and we need to protect the environment. That's why Telangana government initially take you Green India Challenge initiative. They are Harita Haram, right? So they are promoting, right? So they are planting saplings and they are protecting those things. So now we are realized, the governments and the top leaders all over the globe, they realized the environment, how the people are affecting when we are increasing the pollution. So everyone facing the problem. So we need to reduce the pollution. So that's reason, if you are observing here, the renewable energy, whether it's a solar or wind or any the hydro power plant, also from the hydro also we are generating which are coming from the free of cost we are getting from the nature only, right? If you are observing here, the coal in 2018 up to 2018 in India itself, 56%, 0.23% of the generation of the power out of 100% of the power we are generating. But when it comes to the 2019 year, and it will be decreased here, it will be decreased, but the renewable energy cases all over the India, it is increasing 35%. In 2019, it is increased 35%. In case of 2018, we are utilizing 21% only. Recently also 700 megawatt power plant, centralized PV system, centralized PV system recently Prime Minister of India, he started, right, in Madhya Pradesh. So in Andhra also 1000 megawatt solar park also they started. The work is going on. So in Gadwal also 40 megawatt power plant is started. Nizamabad also some renewable energy power plants are started. So every year we need to protect our environment. So the governments also concentrating to improve the renewable energy power, because why we are improving means, as per the IEEE standards, as per the researcher analysis recent report also, whatever the energy sources which we are utilizing now, whether it is a coal or petroleum or diesel, right? The coal, once it will be disappear from the earth, means we can't reproduce that coal, right? So it will take so much time, long time it will take. So here we need to protect the environment. So as per the report, they are suggesting up to 200 years only, whatever the resources are available in the earth, so we can use. After the 200 years, how the world will be sustained? That is a big question, right? So then, so that people are government 19 itself, power it is increasing day by day. Wind power plants, when we are using, we can protect the environment also, and there are free pollution, no pollution, singular and carbon. If you are observing, why thing is we are moving to the smart grid means we need to improve the power quality. We need to improve. We are observing the utility grid which we are taking the power. So here in Telangana state itself, you are considering Ramagunda, people will distribute the power consuming. So we are paying the, as per the report also. So by using this smart grid, we can improve the power quality. So what is smart grid? What is a smart grid means? A smart grid is a modernized electrical grid which sets up an automated two-way communication between the end user, that means customer, and utility to deliver a power efficiency using the information and communication technology. So the basic concept you need to realize, so to monitor, analysis and control and communication capabilities in the we can easily monitor our power, how much power we are consuming every day. Also by using the smart grid system, we can easily analyze how much power every day we are using. So this is 5 to 6 hours time. Automatically we can decrease the interruptions also in case of smart grid. Knowing ourselves also, we are wasting so much of the power. So by implementing a smart grid system, we can reduce the consumption, reduce the energy consumption here. If you are observing, what are the features in the smart grid system, it will come. So significantly, it will reduce the environmental impact of the whole electricity supply system, and it provides the end user for a supply choice of the supply. So security levels, so it will be very secure and reliable operation. In the case of smart grid, bidirectional energy power flow. And here the load means we are the loads, right? So we are the customers, we are taking the power from the grid, utility grid we are taking, right? The load supported by the smart grid will vary periodically depending upon the necessity of the end user. So if you people need the power, means at that time only you can utilize the support the how when the customer needs the power, at that time only we can distribute the power, otherwise no need to distribute. So sources, in this case we need to improve a lot. So everyone need to prefer renewable energy system, means they can generate the power how much their home need. So in cities around we need more than 600 units per month. In rural area means we need approximately 200 units. We have means in rural area we can sustain, right? So we are observing the features of whole smart grid in image color here. Energy generation, storage options also available. So if you are observing, when you are taking the power from the utility grid, is there any option to store the energy? There is no option, right? We can't store the energy. So but in case of when you people are preferring the smart grid system, in this smart grid system storage options are available. And the power quality here, two-way communication, by using the two-way communication we can improve the power quality. By improving the power quality, your load equipment, whatever the load equipment at your home or industrial area, it will come long life also. If you are not getting the quality of the power supply to your domestic loads, whatever it may be, either refrigerator or AC or fan or tube light, these are all the domestic loads only, right? So if you are not using the quality of the power, means these products will may affect, and the long life of the product it will decrease. So then who will if you are remembering, when you are purchasing any product, also, so we are observing the rating, right? Either whether it is a smart 5-star rating or 4-star rating, right? Like that you need to, when you are taking the power also, quality of the power. So whether the interruptions are very high or voltage distortions are very high or any harmonic distortions are high, or as per the IEEE standards they are following or not, when we know, means then we people will get more benefits. And electricity market demand response, so demand and supply and demand, so self-healing in this case are possible in the smart grid system. If you are observing the current grid scenario, current grid and the smart grid you can observe here. In the current grid, localized grid, where we are taking the power supply from the substation, near to the substation, we are through the transmission network we are taking the power, right? So the utility grid and the smart grid in India, if you are observing, so in the smart grid case it will be interacted with the utilities, all the utilities, those who are in the centralized grid connected system itself, we are all connected to the smart grid system, all the customers in a particular location or in a Hyderabad city. So in which area, whether it is in Saidabad or Kukatpalli or Jubilee Hills, the people minute to minute we can easily monitor how much power consumption is going in each area. Also by implementing the smart grid system we can easily analyze. Because by placing a smart equipment, smart home appliances or smart devices at your home application, and smart meters, when you are placing, then you can easily analyze. So here single communication, in this one you can observe here, in the smart home applications, it is a two-way communication, right? You can see here the current grid system which we are taking from the substation, near to the substation, through the transmission lines, from that in between the transmission lines, in near to our complex, near to our apartment also, one transformer is there, right? So by using the transformer, so number of so power system concept, it is a big concept and it is like a ocean and it is a more complex system, right? So when we are taking the power from the distribution itself, from through the transmission network taking, and we are taking the houses, but it is a one-way communication. There is no interaction to the customer and we and the distributed people. So they are giving the power, whether it is a single phase or 3 phase, So when they are giving the supply, that point only we are taking. But in case of we are observing the two-way communication, so in the two-way communication, you can minute to minute by operating this system, you can easily monitor how much supply you need, how much supply you people will need. So then when you need to utilize the load, so when you need to turn on the fan, when you need to turn on the AC, when you need to turn off the refrigerator, these are all the things in the two-way communication. If suppose you don't need the power, at the time you can turn off, you can send the signal to the smart distribution side, so then they will easily stop the power supply to you also. If any interruption are occurred, in this case it will take so much time, at least 2 to 3 hours it will take, right, to reallocate the power. Suppose during the rainy season, due to the lightning strike occur or any fault occur, due to the trees are fall down on the transmission network, means immediately there may be sharp interruption, right, power interruption will be happen. So at the time when we need to reconnect, means we will call to the we will call to the lineman, right? So then the lineman will come and he will monitor all the things and he will reallocate the power. But in case of the smart grid system, we can easily reallocate the power by using some IoT sensors. By using some IoT sensor, we can easily fault monitoring also. We can easily we can easily analyze in the smart grid system, which is a two-way communication only. Here, what the grid will be in the smart city, right? So they are every year they are promoting, they are announcing some smart cities. Through that concept, in India they selected 25 cities. In that 25 cities they are testing, it is in testing level, smart grid concept, it is in testing level. And here, so if you are observing all the home appliances, so by using this two-way communication in the smart grid system, where you can, if you can take the power supply from the wind generation or solar PV plants or thermal power plants also, you can easily, all these power plants will be interconnected. All these power plants will be interconnected. If we are observing here residential applications, so residential application, and here federal building and hotels and factory. So here this factory will need three-phase power supplies. Always these factories or any hotels, they need huge amount of the power. So by here in the residential application, we people need single phase supply only. So we can easily distribute, right? We can easily distribute the generation, transmission, distribution to the customer side also. It will be very easy, right? Where the people need huge amount of the power, right? So now if you are observing 24 in agriculture purpose also, if you are considering the agriculture purpose, the governments, they will allocate some time only, right? Daytime 9 hours they will give full power, otherwise they will give the single phase power supply only at rural area, if you are considering rural area. But industrial area people, they need 24/7 power supply. That means the demand here in the factories or industrial areas, it will be very high. So then the people will monitor this control center. This is the control center. From here itself they will monitor to the residential application how much power supply we need to send. And the federal buildings, so federal buildings are complexes, how much supply we need to send. So then here how much consumption is happened in hotels per 1 day or 1 month, how much consumption is happened. According to that they will estimate, they will send the power to the particular area. So here wastage of the power, it will be very low, right? So by monitoring always through the communication technology and information technology, through the intelligence and the communication, we can easily monitor. So how we need to monitor, what are the key factors here means, in the key factors where we need to observe mainly generation. The working of smart grid can be keyed in mainly 4 steps, right? Generation, transmission, distribution and the end user. So generation side, how much power we need to generate. According to the demand only we can generate the power, right? So every day nowadays all the loads at a home application itself. Most of the people, they have number of smart gadgets are high, and the loads also increases in every home. Previously 10 years back or 15 years back, each and every home they have one fan and one TV, like that only simply. But nowadays all are, they are adopting with AC, and they are taking a refrigerator. These are all the loads, washing machine also. So at that time the demand is increasing at the end user side, so we need to generate the more amount of the power, right? If in case if you are generating the more amount of the power, but if people didn't get the coal, if people didn't get the coal at right time, at that time where you will take the power? From the renewable energy sources, whether it is a solar or wind, you can take that power, right? So you can take that power, you can transmit that power to the distribution side. That distribution people will distribute the power to the customer side also. So all the people, all the power plants, whether it is a thermal or renewable energy sources or wind power plants or hydro power plant, they are interconnected. They are interconnected. So if you are observing the hydro power plants, when we will get the maximum power? During the rainy season only we can generate the high amount of the power. But in the summer time, automatically they will stop the generation of the power, right? So according to the situation, in the smart grid system, where we can generate the more amount of the power also, it will be available. Suppose in the distribution intelligence, so if in case blackout due to the bad weather conditions, any fault occur or any something happened in that power system network, means we can easily recollect that one. We can easily counter effect that one. You can observe this one, smart grids counter effect, and repercussions of counter effect also you can observe. So distribution intelligence we can easily monitor. So here, when we people are transmitting the power, if any something happened in the power system network, then it may damage through the due to the bad weather conditions in the atmosphere. So then we can easily distribute the power within the less time. Within the less time we can easily monitor. If you are observing the smart meter, so the end user, if you are considering in the case of end user, how the end user will monitor? Suppose in our domestic applications, we have one bedroom and a kitchen and a hall and everything will be there, right? So if you are turning on the fans, if you are turning on the bedroom, but you people are sitting in the outside of the house, you are sitting, you are chit chat. At that point, here in this case it is wasted, right? The power wasted in the a bedroom or a hall. So by using the smart meter app, that means whatever meter we need to replace with that one, with the smart meter, by using the smart meter. So this is a smart meter, right? By using this one, by replacing with the smart meter, all the appliances we can interact. All the appliances, whether it is a refrigerator or TV or AC in our home application. Suppose coming years we can see the e-vehicle also we can see, right? So when normally generally the people will use most of the power during the peak hours only, right? Peak hours means everyone will know, during evening 5 p.m. to at night 10 p.m. In cities means it is around 11 a.m. 11 p.m. also it will be, that is the peak demand, right? So in that particular time only the people will use most of the power. So at that time, which loads we need to operate, which loads we need to stop also, by using these smart meters, we will install one smart app in our mobile phone devices. Then we can easily monitor our fan, our phone, or our AC also we can easily monitor by using the web application. Or smart app in your mobile phone itself, you can easily stop all the things where we are wasting the power. So here everyone will know how much works we people are working, how much time we are working, how much hours we are spending with the kids. Everyone will know, right? How many hours we are going to outside of the home also we people will know. So then according to that we can easily plan. So the requirements of a smart grid, what we people will need means smart thermostats and light occupant sensors or home automation system, smart grid relay appliances,
smart energy glass, smart meter, phasor measurement units. What these phasor measurement units will do means, the phasor measurement unit, synchro phasor, everyone will know. We are talking about the power quality, right? How much magnitude you people are getting at your home. How much magnitude you are getting, whether you are getting the quality of the power or not. By using the synchro phasor technology, these phasor measurement units will monitor the power supply. The magnitude, how much we are getting, with how much angle we are getting. If you are observing the transmission network, they are maintaining with 120 degree only, right? So this, by placing the phasor measurement units across in the transmission network, then we people can easily identify how much power supply we people are getting and how much magnitude we are getting, how much magnitude we are sending to the fan, how much magnitude we are sending to the AC, how much magnitude we are sending to the refrigerator. These are all the things we can easily monitor. So this smart meter and smart energy glass also. So if you are observing the smart thermostater or thermostators or light occupant sensor, so it learns when you wake up. So when you people are wake up at your bedroom, so to adjust the temperature for a comfortable way, setting before your feet hit the floor in the morning itself, by using these thermostater devices, you can easily monitor how much temperature at your room you need, whether you people will need 25 degree or 40 degree or 60 degree. Normally we will leave below 40 degree only, we can comfortable. What is the comfortable temperature you people will need? These thermostaters will monitor. So what this light occupant sensor will do means, this light occupant sensor, when you are placing on your fans, when you are placing on your fans or lights means, then by using this sensor devices, this light occupant sensor devices, you can easily stop and turn on and turn off your fans also, turn on and turn off your lights and fans also. So here, to wasted the validation. So why we are preferring this one? We are to wasted the energy is a motion to activate the lightning sensor. So in this case also, we can use the home automation system by placing a RFID sensors. So then we can easily monitor by using any IoT sensors. So by using any IoT devices, when you are placing, by using some programming code, we can easily monitor through all the devices at our home application. In that smart home itself, we can easily monitor by using the home automation system. So if you are observing a smart grid ready appliances, so you need to install this power control. So you need to control. So these are the smart fridge or AC or TV or washing machine. These are all the smart grid appliances only, right? So these, suppose in your mobile phones itself, you need to keep by using the Wi-Fi module or Zigbee you need to take. So by using the Zigbee, you can connect all the devices at your home application. Then you can install one app in your smartphone. Then you can easily monitor minute to minute also how much power consumption happened in our home, at our bedroom or at our hall also. So we can easily monitor. So by using a smart energy glass also, with these type of windows, one can control the intensity of the natural light that penetrates the room and it will collect the generator. These smart glasses will generate some energy, will generate natural, it will take the natural light. Otherwise you can put solar PV panels also. Sorry. You can put the PV panels by using the PV module panels. Then you can generate the power. You can on top of your 600 units per month, right? 600 units you are considering means, then you can prefer 3 kilowatt of the PV plant at your top of your home. By connecting the 3 kilowatt of the PV plant, every day you will get 12 units from 30 days approximately. You will get 360 units. So that means how much your consumption at city. If you are stay in city means you are consuming nearly 600 units your estimation. So by using the 3 kilowatt PV plant, you can generate 360 units per month. Per month you can generate the 360 units. But you need to 240 units more, right? So then you can go with the 6 kilowatt of the PV plant. 6 kilowatt of the PV plant if you go with. So then you can generate you can generate more amount of the power. That means 720 units you can generate. So you are using 600 units, remaining excess power you can give the grid, otherwise you can store that energy in your battery also. But you can give the grid means the grid people will pay the electricity bill to you only. So when you are preferring the rooftop solar PV panel, so the Madhya Pradesh government, they are initiatively taken. They are started to all the home appliances, rural areas also. They are promoting to encourage the people to install the rooftop solar PV panels on top of your home. You can generate the power, you can utilize the power. If you are getting the excess power means you can give to that power to the grid means that grid people will distribute that power to those people who need it. Those people they will send, and then they smart converters can be used in an appliances which converts the AC current to DC also. Smart converter, that means power electronic converters. Power electronic converters, everyone know power converters, whether it is AC to DC or DC to DC, DC to AC. By implementing these type of converter topology, we can easily reduce the wastage of the power. So, and multi-wire connection must be avoided. We can avoid the multi-wire connection, and smart wiring we can use. We can go with that one. Use of the smart switches, use of the smart technology, smart home. By using these techniques, we can save the energy, save the power energy also in this case. So here, if you are preferring the smart home, on top of your home, when you are placing the solar PV plants and the wind energy. So in this PV panel, so if you are going with this like this means solar rooftop solar PV panels, man, it is a decentralized PV system. It is like a decentralized power. That means each and every home they need to install on their as per their requirement on top of their home. So you can go with the smart solar PV plants and the wind energy power. So if you are going with a 3 kilowatt PV plant, 3 kilowatt wind power plant means then you can generate all the power, right? You can generate the power at your home itself. Then you are giving to the that supply to all your loads. But here, if you are observing the PV power plant, what is the power you are getting? DC power only you are getting. That means photovoltaic energy, it is converting into the electricity. But in case of wind turbines, the mechanical energy is converting into the electricity. But there in wind turbine, we are getting the AC power, but in case of smart PV power plants, we are getting the DC power. But we need to convert that AC power into DC power. Then only we can store the energy in the form of in the battery, right? So we can go with the smart appliances in that smart technique. As I said, AC to DC energy in your battery. Suppose if you are using the mobile devices. You are using the mobile devices means you need DC power supply only. So you can take that DC power directly. But when you need to turn on your tube light or your fan, you people what you need? AC power only you need. Then you can go with the smart converter. Smart converter means DC to AC converter, one inverter, one converter. DC to AC converter if you are preferring means that inverter will convert the DC power supply from the battery to AC power. Then you can turn on all your tube lights and fans, and you can run all the loads at your home application itself. So here, these by using the centralized PV grid system, there may be some drawbacks are there, because when you are transmitting the power quality issues will come. In connecting the number of PV plants, you will not get the same amount of the power. The temperature conditions in the Saidabad and the Kokatpalli, it is different, right? The temperature may be different. Solar irradiation, that means the temperature each panel will take differently. So according to the panel, how much power it will generate, when the maximum temperature will come means at the time it will generate the maximum power. But if the temperatures from panel 1 to panel 10, it is different means automatically voltage mismatching problems will come up. So then we need to overcome those mismatching problems. So that's the reason most of the people they are suggested you can go with the decentralized system. Decentralized PV system. In that decentralized PV system means if you going with, you can install at your college itself. How much power you people will need per month or per day? How much power you need? On top of our college, if you are installing the PV power plant, solar PV power plant, you can generate the power. You can utilize all that power to all your smart devices. That means laptops or smart systems. Everything you can utilize that power. But we need to follow the techniques. Then after few days, a few months later also, the panel may shade out. So then you need to monitor. You need to monitor the PV panels. You need to clean the particle. Dust particles will be cover up, right? Initial stage it will be normal only, but after a few months the dust particles will cover up with the solar PV plant. Then the voltage generation, how much voltage, how much current you people need, so it will be very less. So then you need to clean the solar PV. You need to monitor the solar PV panels. So here the limitations, what are the limitations of the smart grid have? Smart meters will be more accurate than the current electromechanical meters, and hence the customer electricity usage will be tracked more accurately and they may see higher bills. If you are observing, when we are in lockdown, 3 months lockdown, at the time everyone are in shock, right? So we are getting the power bill huge manner, right? So everyone they are paying the electricity bill up to, normally when they are getting 1500, like that means at the after 3 months they are getting huge amount the people are getting, right? So here by using the smart meter we can easily track the power, how much at our home we are consuming. We know how many loads are there at our home, then each load how much to the new meter. So we need to we need to attract the people first. We need to we need to aware the people. So by using these smart meters, you people will get so more benefits. You can prefer this smart technology, smart grid system. Like that, we need to give. We need to aware the people. So ensuring the security of metering data, it will be more secure, and protecting the privacy of the personal data also, and paying additional fees for the new meter. If consumers continues to use more and more electricity, it would negotiate the project and the environmental benefits also, and disposal of the old meters here. These are the limitations of the smart grid system. So to integrate the renewable energy sources, to integrate, what we people need to do means to integrate the renewable energy sources. We need to promote, like anything, renewable energy sources we need to promote. So in this renewable energy sources, to get the quality of the power, to get the high efficiency, means we need to use these converter topologies, power electronic converter topology. So DC to DC, or DC to AC, or AC to DC, or AC to DC also we can utilize. So switches and disconnectors, availability of the domestic DC appliances, power packs, and connectivity of the grid, size of the plants, and distance to the, how much distance we are maintaining with the consumers also from the grid connected system, and control strategy and methodology, available of the software also we need to check, right? Nowadays each and every people they are getting the free net only, right? So they are the data, it will be cost of data, it will be very low only nowadays. So the people will get the technology very with a cheap cost. So we can easily promote the smart grid or smart meters or smart energy system by using to monitor the power intelligence in the grid connected system. We need to integrate the mainly renewable energy sources. In that renewable energy sources, to get the maximum power, we need to use these converter topologies, smart converters we need to utilize. So to implement the implementation of the smart grid technologies, so government of India pilot project in the northern region, North India side, they started under the power grid, in association with the power grid, they started intelligent monitoring and control of the interconnected electric power grid using the wide area measurements for western region. So in Rajasthan, Gujarat, they started. So here in North region pilot project, they are placing phasor measurement units with the GPS system to be installed at for 4 substation in the northern region and near New Delhi, for by using these phasor measurement locations in a 400 kilowatt PV substation in Kanpur also, and Vindhyachal HVDC, Vindhyachal, and Dadri HVDC. So HVDC also coming years will some fact devices. Every people will know, right? Why we are using these converter topologies means fact devices will play a key role to improve the power quality issue, to improve the power quality, to reduce the power quality issues, and to improve the power quality. Fact devices, all of you know, right? So DVR or D-STATCOM or shunt active filter, and UPKC, IUPKC, these are the fact devices which are giving the high efficiency, and it will improve the power quality also. And here, what these phasor measurements, as we discussed, to control the magnitude. So, and by using the synchronophasor technology, it will monitor the magnitude and the phase angle it will monitor. So, at the same time in the North India side, a pilot project they started in Gujarat, North Gujarat, Vidarbha. In North Gujarat, Vidarbha side, they started one pilot project. So, 20,000 houses they installed the smart meters. Nearly 20,000 houses they installed the smart meters. By installing the smart meters, every 15 minutes they are monitoring the customer how much power he is using, whether the customer is wasting the power or the customer utilizing the power with a purpose or not. So by their pilot project they started in North Gujarat. So by in a 20,000 houses they install the smart meters. So by using the smart meters, every 15 minutes we can easily monitor the customer. We can easily monitor the customer also. So here in this intelligent monitoring for controlling electric power grid using the wide area measurements. So this project approved by the CSIR, everyone knows CSIR, Council of Scientific and Industrial Research, under New Millennium and Technology Leadership Initiative. And along with the power grid, other members in this consortium are TCS, it is providing the software, and IIT Bombay, they are the technocrats, they are monitoring, and Tata Power Company Limited also, they are in this project, they are under this project, they are monitoring. So in Pondicherry also, power grid, phasor measurement units, in Kerala government also, they are invested $10 billion in the smart grid system. Coming years, we can see the smart transformers also. 1 kilowatt, 2 kilowatt, 3 kilowatt. Nowadays, if you are observing the smart transformer, how much size? It is in lakhs of cost, right? So coming years, we can expect smart transformers, which are giving 1 kilowatt or 3 kilowatt of the power supply only. So why we are discussing these smart grid technology means to integrate the isolated technology. Smart grid enables better energy management. Here we can betterly we can manage the power supply and proactive management for electrical network during the emergency situation, and better demand supply and demand response management, better power quality, reduce the cost. We people need smart grid. We people need smart grid technology. So to improve this one, so to deliver sustainable energy and to increase the efficiency, empower the consumers, improve the reliability by using this smart grid technology. By using this smart grid technology, what are the new technologies coming means energy storage to support a resilient smart grid, comparing the evaluate cost, competitiveness of the compressed air, pumped hydro, and ultra capacitors, flywheel, battery tech, fuel cell. So energy for the energy storage in the smart grid technology, not only batteries. So for fuel cells also, the best way we can store, as I said, electric vehicles will come. So when you are using the peak demand, so when you are using the peak demand, you need to store, you need to charge your vehicle, right? So in that vehicle also, if you are, it is in a fully battery electric vehicle or purely plug in the electric vehicle means, in that vehicle the battery capacity, it is around 40 kilowatt of the battery, more than that also some companies are producing. So Nissan Leaf type of electric vehicle cars, they are in 40 kilowatt, which is running with the more than 350 kilometer speed. So they are in that vehicle, the battery capacity itself 40 kilowatt. So and the weight of the battery also, it is around 400 kg. So at that point we need a high amount of the power. So peak demand, we need to stop that electric vehicle. So remaining time during the night time, people temperature is very high, but during the night time only wind flow will be very high. So at that time we are generating the power, right? We are installing a 3 kilowatt of the smart grid. So wind grid, right? So from that we can generate the power. We can store that energy in our e-vehicle also. We can store that energy. So here I will show one simple MATLAB Simulink model here. Wait a minute. So whatever the smart grid technologies we people are talking about, but in this smart grid technology also, everyone know already. Most of the people they know how we need to design a product when we are implementing, when we are discussing a 3 kilowatt of the grid, suppose 1 kilowatt of the PV plant, how to design, how to implement a new product for a new product or a new grid connected inverter also we can see here. Now, this is a MATLAB, millions of engineers across the globe, millions of engineers are working, researchers are working to design and analyze the product, real-time products, whether it is a e-vehicle, whether it is a solar PV system, whether it is a smart grid system. By using this one, by using the MATLAB software, they are implementing their products. So here in this product, not only electrical engineers, electronics, communication engineers, all the people, all the technical department people, they can utilize the MATLAB solution. MATLAB have number of toolboxes are there. More than 100 toolboxes are there. Across the globe also, more than 6,500 universities, they are working on MATLAB solution. So not only in a smart grid system, we can utilize in the renewable energy system or aircraft system, defense system, and ISRO space technology also we can utilize these MATLAB solutions. So here, whatever here you are observing here, this is a command window. In this command window, whatever the variables if you are typing, it will appear in the workspace. So this is a this is the current directory path, this is the current directory path, and this is the current folder. Here I will show a on-grid solar on-grid inverter. Here we will see a solar on-grid inverter. You can see here a solar on-grid inverter. So here this is the solar PV plant. Solar PV plant. Solar panel, in real-time application, we people will get the sun temperature directly to the on the solar PV plant, right? So from here, by taking a signal builder, by all these blocks we are taking from the library browser only. This is a Simulink library. From this library browser we are taking. So if you are observing, this is the signal builder. In this signal builder condition, here I am taking 25 degree. And this one is the signal builder. Irradiation, depending upon the temperature condition, it will be vary, right? At some time the irradiation temperature 1000, and at some time the temperature may be increased. During the afternoon session the temperature may be peak, right? So depending upon the temperature, 4 solar PV modules in series plant. From this solar PV plant, by connecting a boost converter, this is a boost converter. So why we are connecting the DC to DC converter topology or power converters means, here with that point when we are utilizing this one, so when we are not getting the required power to the grid side means, at the time when we are using this converter topology, DC-DC converter topology, boost phase grid connected inverter, by using a single phase converter, single phase converter we are connected, then we connect it to the grid side, right? In this grid side we need to get the single phase grid only. Here we need to get the 3 phase single phase supply, 220 or 230 we need to get. So here when we people are taking this solar PV module, in this solar PV module we are taking each panel we are taking the 250 wattage panel, that is 250 wattage panel. One panel it will give 250 wattage. So, and 4 panels means it is around 1 kilowatt of the panel we connected. So from that nearly 400 voltage here we are getting. By getting the 400 voltage, we are giving this single phase grid connector. Most of the people commonly used blocks, aerospace blocks. Here we are interfacing with the Simulink and the SimScape. As an electrical engineer, we can use these 2 toolboxes, then we can design our model also. If you are observing here, when we are connected the 4, to avoid the voltage mismatching problems, we need to add the MPPT algorithms. So in that MPPT algorithms also we have network algorithms also there. So here 9.86 it will give, and here we take data sheet Trina Solar TSM module only we are taking, parallel string
Here this solve degree condition, the converter will improve the inverter controlling part. This is a single pin. So but here we need to reduce the ripple level voltage. If you are improving the 400 voltage